Talked about descriptive research methods, and as we said, descriptive research methods are lovely if you want to describe, explain, or predict, but cannot do control. Experimental research methods allows us to tackle that last goal of science, to control, okay, to establish the A causes B laws of the universe. Okay? So clearly, if we understand cause, as we said, if we conduct an experiment, we can get A causes B. More specifically, changes in the independent variable cause changes in the dependent variable. Okay? So we'll come back to that. So an independent variable is the thing that is manipulated in a research study. It is similar to a predictor, as we talked about in correlations. That is the thing that comes first. Okay? The dependent variable is that thing that we measure. Okay, we the researchers measure this, and the dependent variable is similar to a criterion or an outcome. So we manipulate the independent variable and measure changes in the dependent variable, or changes in independent variable cause changes in the dependent variable. Okay? So in order to make this simple statement, we have to address, and you'll learn much more about it in a research methodology course, but we must address things such as extraneous variables. So extraneous variables are sometimes called noise. And noise is things that you're not manipulating them, but there's just sort of like some of the participants are male and some are female, and some are hungry and some are tired and some are happy and some are, so this is noise. And the more noise you have in an experiment, the harder it is to establish A causes B. Okay? And so there's solutions to this noise. Number one, you can hold them constant. Say, for example, you could make sure all testing is done in the exact same room. All testing is done on the same type of computer. Whatever it might be. All participants sit 18 inches from the screen, the monitor. I mean, whatever you want to do, you can hold them constant. You can manipulate them. You could say, oh, if you had some males and some female, you could use that as sort of like an independent variable of sorts. Okay, you could do that, and other ways as well. But you want to control these things as best as possible. But extraneous variables are bad, and we call them noise. But if you have a confound in your research, then you're dead. Okay? And so an extraneous variable that is systematically manipulated or systematically changed with the independent variable becomes a confound. An example of a confound would be if, say, for example, you brought you were testing an experimental group and a control group, and you were doing like group testing. So you brought in all of your experimental group in the morning, and then all of your control group in the afternoon. And then you found a significant difference between the experimental group and the control group. You rejected the null, and you're like, "Ooh, look what I found." But is the finding that you have the result of your experimental manipulation, your independent variable, or is it a function of time of day? Because clearly people react differently in the morning versus the afternoon. So it's very possible if you have a confound that you don't know why your finding is true. Okay? So you cannot make causal statements if you have a confound. Okay? So here's the basic process of an experimental research design. Okay? We make uncontrolled observations, sometimes, like we said previously, descriptive research, for example, to create the observations that are necessary to feed the system in the first place to generate a theory. Once we have a theory, we formulate a testable hypothesis, an if-then statement. If this happens, then this outcome will occur. Okay? So we're going to design the research, and then the predictions are going to be very similar to the hypotheses, but the hypotheses are going to be vague. Like, if people are happy, then they'll be helpful. Okay? So if independent variable, then dependent variable. But now all of a sudden when you get to the prediction stage, you'd have to be if, not just happy, but if people are given a reward, then, not just helpful, but then they will help the researcher with some task. Okay, so you're going to have to quantify at this stage. Okay? So once you have your specific predictions, you're going to gather your data. Then comes your statistics. Here's where your statistics is going to, if you remember, reject the null, fail to reject the null. So your statistics are going to make some decision in relation to the hypotheses which were generated from the theory. And so now we feed back into the theory and modify the theory as needed based on the results from the statistics. And then the process moves on again. Okay? So in order for research to be an experiment, it must have one thing, and that's called random assignment. Random assignment is, let's say you draw a random sample of 100 participants and you want to put 50 in the experimental group and 50 in the control group. Random assignment means you must be able to take all 100 names and basically throw them into a jar and shake them all up and then pick them out. You're in the experimental group, you're in the control group, you're in the experiment. If you cannot do this simple act of randomly assigning participants to conditions, you do not have an experiment. I don't know what you got because I don't know your study, but if you cannot do this one simple task, you do not have an experiment. And if you do not have an experiment, you cannot make statements of A causes B. Okay? Very straightforward. Well, it turns out experiments can be done in laboratory settings or in field settings. Well, it turns out lab settings are better in some ways because you can control things. You can make sure that all participants are being exposed to the same things. They have the same. So you're going to do something where we're going to say a lab experiment has high internal validity, which we'll talk about in a little while. But what happens is when participants come into research studies, they act weird because they're looking around. They're like, I wonder why I'm here. What do they want from me? And so they sometimes in a laboratory setting, though you can control it better, the participants will not act like they normally act. Okay, they act like they're capable of not what they actually do. In a field experiment, you're much more likely to see real, actual behavior that reflects reality. But because the field experiments are done in an uncontrolled setting, they have very low internal validity. But field experiments tend to have high external validity. So we find that often what happens is researchers will establish a theory in a laboratory setting and then test it again in a field setting. And if you have replicated the finding in a lab and a field, when one has high internal validity and one has high external validity, put them together, you got the package. Okay? And then finally, a quasi-experiment. Be careful. Quasi-experiments look like an experiment. It looks like you have an independent variable that you're manipulating. But one of the most common ones in quasi-experiments is gender. Do males and females in my factory have different performance outcomes? And so you're going to measure males and measure females, but you could not randomly assign male to female. So don't you dare make statements of causality in your findings. Okay? All right, so that's what we have on experimental research.